Okay, welcome to this weekly. The first question here that we're going to look at is, given the equation y equals 1/2 x minus 4, is the point 0, negative 4 a solution? This question here is asking us to figure out, does the point 0, negative 4 satisfy this equation? Does it make this equation true? If it makes the equation true, it means that this ordered pair lies on that line. It means that line goes through this ordered pair. In order to determine if it is a solution, let's treat this as an ordered pair. It is an ordered pair. Let's treat it as x comma y. Let's substitute in these values for x and y. So what we would have is negative 4 equals 1/2 times x, which is 0, and then minus 4. And bring down our negative 4. 1/2 times 0 is 0. 0 minus 4 is negative 4. This checks out. Since we have a true statement numerically, we know that this solution satisfies the equation. It makes this equation true. This is a solution to the equation. Thank you, and please stay tuned for the question that follows. Okay, let's look at this next example. It says the graph of a linear equation contains the points 5, 3, and 6, 10. Does the point 8, 23 also lie on the graph? It would be helpful to know the equation that the first two ordered pairs go through or lies on. So what I would do is write the equation, then check to see if 823 is a solution to it. So in order to write the equation, I am going to first of all need to find my slope. So I have x1, y1, or x sub 1, y sub 1, x sub 2, y sub 2. We know that our slope formula is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. When I substitute in the values, I will have 10 minus 3 divided by 6 minus 5. What that gives me is 7 over 1, or 7. So my slope is 7. I'm going to find my y-intercept at this time. If I had a ordered pair up here that would have been like 0, comma, a number, that would have been the y-intercept. But I don't have that, so let's go through and actually find b. So when I find b, my y-intercept, I'm going to use my y equals mx plus b equation. Let's choose one of the two ordered pairs given to us. They both are x, y. It does not matter which one we choose. I'm going to choose the first one. Y is 3. We found m to be 7. And since I chose the first ordered pair, x has to be 5. And then it's plus b. So I get 3 equals 35 plus b. And this is simple solving for b. So we are going to have a negative 32 for b, our y-intercept. My equation here, my equation is y equals 7x minus 32. Now, the question says, does the point 8, 23 also lie on the graph? Well, this is like the question that we just looked at. Check to see if this point satisfies the equation. If it does, then the line goes through that point. Let's see. We have 23 equals 7 times 8 and minus 32. So we have 23 equals 56 minus 32. So 56 minus 32 should be 24. 23 does not equal 24, so no. 8, 23 does not lie on the graph. Thank you, and please wait for the question that follows. Okay, let's look at this next example. It says, given the equation y equals x squared plus 2x minus 6, is the point 4, 25 a solution? Well, this right here is a quadratic because I have an x squared. All I need to do here is to make sure I'm careful when I square the x value. We know that we have x comma y. Right, that's in the ordered pair. And as long as we find this to be a true statement after substitution, well, then we would know 425 is a solution. Let's check. We have 25 for y. X is 4, so we would have 4 squared plus 2 times 4, and then minus 6. So bring down the 25. 4 times 4, that's 4 squared, 16. We have plus 8 minus 6. So 25 equals 16. Let's see. I guess what I'm doing here is looking at a plus 2. What we have is 18. 25 does not equal 18. So is 425 a solution? No. No. 4 comma 25 is not a solution. Thank you. Please wait for the question that follows. Okay, let's look at this example. This is different from the previous examples in the fact that I don't need to find the slope. I do have the equation already, but it's not written in y equals mx plus b form. If you would like to rearrange it so that it is y equals mx plus b, you could solve for y. It's not really necessary, however. You could simply look at this question and say, well, I have an ordered pair. We would like to know, is that ordered pair going to satisfy this equation? Meaning, does that equation, if I graph it, pass through 1 comma 4? Does 1 comma 4 make this a true statement when I substitute it in? Let's just substitute in and see. What we would have here, 4 times x is 4 times 1. And then here is 4 times y, which is 4 times 4. And does that equal 20? So we would do the multiplication and get 4, 16. 4 plus 16 is 20, so 20 equals 20. That checks out. I would say at this point, yes, 1 comma 4 satisfies the equation. If you would like to solve this graphically as well, you could graph that equation if you solved for y. And then you could trace the graph on your calculator and see if it does go through the point 1 comma 4. But that is not necessary here. Thank you, and please wait for the question that follows.